Alrighty, so we're looking today at transposing equations. Often this is called rearranging. I think this is the most important skill that you'll probably learn in this course because it comes up time and time and time again. And it's one of those things that if you don't do it well now, it will continue to plague you to go through senior. This can be the difference in a kid's result over a grade. If they can't do this well in senior, they can nail things like differentiation, calculus, trigonometry, but if they can't rearrange and effectively transpose their equations at the end, they're not going to be able to solve or prove their understanding. So the first thing we're going to do is look at an example, I guess, to try and give you an idea, to help you visualise what we're doing and how we're going about doing this. So the example I've given us is negative 6x squared plus 10 equals negative 14. And I'm going to follow a pretty I guess, scaffolded and routine way of approaching this problem, because if you do this, if you follow the rules, then you don't get yourself into trouble. Okay, so when you start breaking the rules, you sort of get yourself into trouble. In younger years, I make kids draw balance beams to show that there is an equivalence, so that the left-hand side of the equation equals the right-hand side of the equation, but I'm not going to make you do that. What you do need to remember at all times is that we need to keep that equivalence. Therefore, whatever we're doing to one side, we need to do to the other side, and we never, ever, ever just move. Okay, we always use opposite operations to cancel, but I'll explain that. Okay, so the first step in our process is to identify the variable that we want to get. So the thing that we don't know, we want to get that by itself. So I need to identify what that is. And for me, in this example, that's x. So I want to get x, and it's often x. It could be anything though. It could be a square, it could be y, it could be q, it could be t. It could be any number of symbols. X is the most commonly used, so I'm just going to use that today. We want to identify that variable, or the unknown, you can use either. It's actually an unknown in this scenario because it's got one set value, but that doesn't matter. I want to identify what that is. Now to find out what that is, I need to get it by itself on one side of the equation. It doesn't matter whether it's the left or the right, I just need it by itself on one side of the equation. So I've got a line that says x equals ... To get that, the first thing I do is look at the operations that are applying in my formula here, or in my equation, and identify, well, I've got a, so I'll go through this now. I've got a plus here, I've got a negative 6 multiply, and I've done this very intentionally. That's a multiplication, that's not a subtraction. So I've got a negative 6 multiplication, that's an addition, should be addition. I'll put that as a time so we're not getting confused. And I've also got an index. Okay, now times is another word for multiplication, obviously I just didn't want to write that out. So I've identified the operations. Now I need to use reverse BOMDAS to identify what I want to attack first. So BOMDAS is how we solve, brackets, indices, division, multiplication, addition and subtraction. I want to use that in reverse when I'm trying to decide what to attack first. This isn't a rule, but it does make things a lot easier when we're going about this rearranging process. I'd recommend doing it. You don't have to, but that's something I like to follow pretty strictly. So as you can see, I've got a times, an index and an addition. If I was using reverse BOMDAS, the first thing I would attack is the addition. Then I'd go to the times, and then I'd go to the index last, okay? So I'm going BOMDAS, but I'm going in reverse. To get rid of these operations, I don't just move, I do the opposite operation. So if I want to get rid of this plus 10, the opposite operation to an addition is a subtraction. So I'm going to subtract 10, not from one side, but from both. I'm going to physically cancel. I'm then going to solve and repeat steps 2 and 3. So again, I find the best way to do this, rather than talking at each other and giving you too much information, is to go through and actually solve one. So right here, I've got the exact same example, just with a bit more room to operate. The variable I want is x. So my last line should have something x equals ... Okay, that could be on the left-hand side or the right-hand side. I've got as much. It could quite as easily be x equals ... As it's already on the top on the left-hand side, it's probably where it's going to finish, but that doesn't need to happen. That's just a convention that we tend to follow. Okay, so I've got negative 6x squared plus 10. Again, I go through and identify what are the operations I've got at play. I've got an add 10, a negative 6 multiply, and it's squared. So the first thing I want to do is get rid of that 10. I don't just move it. I use the opposite operation to get rid of it. So I use minus 10, minus 10. I've done the same to both sides. I haven't broken that balance beam. And now instead of that being moved, it's cancelled. So I physically put a line through and show where it's cancelled. So that's step 2. Step 3, I've applied my opposite operations. Step 4, now I need to solve and repeat. So I've got negative 6x squared equals negative 14 minus 10, which is negative 24. Now what I have remaining, that is not a subtraction, that is a negative 6 multiplication and an index up here. So reverse BOMDAS says that I have to attack the multiplication first. So to get rid of a negative 6 times, and it's probably a good point actually to bring up that little convention because I've said that's not a subtraction, but I haven't explained that. When we've got a number next to a letter or a symbol or an unknown, the convention is that inside that there's a little hidden multiplication, so be really, really aware of that. So to undo my negative 6 multiplication, I divide by negative 6, so both sides are divided by negative 6. On the left hand side again, so I haven't moved it, I've just applied the same operation to both sides. I now cancel. I'm left with x squared equals negative 24 divided by negative 6, which I know the negatives will cancel. That equals 4. X squared equals 4. Again, I'm going to go back to step 2 and 3. As I've only got one operation left, I only have to cancel or undo one operation, which is a squared. The way that I undo or do an inverse operation to a squared is to square root both sides. The squared and the square root cancel. I'm left with x equals the square root of 4, which is 2, or for the extremely mathematically astute, plus or minus 2, but I'm more than happy for that just to be 2 at this stage. Okay, what I want you to do now is to go through and practice a couple of examples, because there's nothing like practice to get your head around it. Just remember the steps and remember the few of the key rules. I'll just remind you about those. First thing we do is identify the variable. Okay, the variable that we want to attack, or the unknown. Then we start looking at the other operations that are at play inside that equation. I will alert you to some conventions as we go further through it, but for now we'll just get our head around the idea of we're trying to use reverse BIMDAS to identify the order in which we want to attack these problems. I pick my first thing as I'm going back across. I then, to remove it, I don't just throw it over the other side or do some special operation. I pick the opposite operation, I do the same thing to both sides, and then I cancel, I solve, and then I repeat. Okay? If you follow that process absolutely religiously, you will not get yourself into any trouble. Make sure you're doing that. It's a really, really important skill, and one that will definitely impact your future success in this and in physics. Cool. Leave you to it.